In this video, we'll be taking a look at the general purpose I/O or GPIO for the G100. Also covered will be binary inputs DI, binary outputs DO, analog DC inputs AI, GPIO configuration steps, the GPIO Map File analog input tab, the GPIO Map File digital input tab, and the GPIO Map File digital output tab. And lastly, we'll look at the GPIO Runtime Point Details. With that out of the way, let's jump right into it. For applications and setup requiring only a few I/O points, the G100 comes with a built-in general purpose I/O or GPIO interface. If this is not sufficient, D.20 I/O modules can be easily configured and connected to the G100 to extend the available physical I/O capabilities. The available GPIO signal types are as follows. Binary inputs, 8 channels, DI wiring is via a pluggable connector, pitch 3.5 mm x 16 pins, located on the bottom side panel. Binary outputs, 4 channels, DO wiring is via a pluggable connector, pitch 3.5 mm x 8 pins, located on the top side panel, analog DC inputs. 4 channels, AI wiring is via a pluggable connector, pitch 3.5 mm x 12 pins, located on the top side panel. All GPIO binary input channels are wedded internally from the main power supply circuit using a single common. Each DI channel can be triggered by the NO normal open potential free external contacts, with the wedded positive voltage being switched through the external contacts. The DI voltage supply is the same as the G100 power supply, 12, 24, 48 volts DC, with each DI channel consuming typically 5 milliamps. Note, the DI wedding voltage is protected internally by the main fuse. For GPIO DI connector pin assignment, the small arrow on the left indicates pin 1. For GPIO DI LED indicators, each DI channel is indicated as an input active on at runtime via a numbered LED located on the front side of the G100. The G100 is equipped with 4 GPIO binary output channels. Each DO channel is isolated and independent and provides an NO normally open dry relay contact, rated at 10 to 60 volts DC/1 amps max. Note, the DO channels are not fused internally. The DO operation types are pulse, latch on, and latch off. At runtime, commands received as close on are translated to latch on, and commands received as trip off are translated to latch off. The pulse command types are executed as pulse according to their associated count and duration parameters. For GPIO DO connector pin assignments, the small arrow on the left indicates pin 1. For GPIO DO LED indicators, each DO channel is indicated as active on at runtime via a numbered LED located on the front side of the G100. The G100 is equipped with 4 GPIO analog DC input channels. Each AI channel is configurable via internal jumpers as full scale, either plus 5 volts DC, the default setting, or 20 milliamps. The resolution is 12 bits plus sign, self-calibrating. The jumpers JAI12 to JAI15 for voltage or current input selection are located on the GPIO internal board, and their settings are 1 to 2 default voltage, 2 to 3 current. For GPIO AI connector pin assignments, the small arrow on the left indicates pin 1. Note that in the pin description, _CHS is the shield connection for each AI channel. All CHS are common wired internally. For GPIO AI LED indicators, AI sampling is indicated at runtime via 1 LED for all AI channels, located on the front side of the G100. The typical sequence of steps involved in configuring GPIO using DSAS MCP Studio's configuration tool are as follows. Access the offline or online editor for the G100 device. Click on the GPIO block located under local I/O connectors in the connections tree. The block settings window on the right pane will display the default line ID/bay ID/device ID for the GPIO, along with the default map file, GPIO_template.xml. Auto startup is enabled by default. This setting indicates if the GPIO application automatically starts when the configuration is changed and reloaded, or when the MCP reboots. The line, bay, device ID can be populated with unique names. The map file can be edited or changed. Select the map file and click the Edit button to view and/or modify the map file as desired. Once done with the editing, click Save and enter a new name to save the map file. Note that the default GPIO_template.xml file can be modified but not deleted. In this case, an edited map file has been saved. The drop-down menu allows using the default template again along with any modified and saved map files. Click Save followed by Commit Change. The GPIO map file editing window contains 3 tabs for editing analog input, digital input, and analog output. Within the analog input tab, the total number of AI points is 4, and this cannot be changed. Point ID, the internal point ID assigned to the point, cannot be changed. Point reference, a short identifier for the point in the map file. Point description, a detailed and localized description for the point in the map file. The multiplier-scale factor of the point, M of formula mx plus b. The injected current/voltage on the specific analog input value is multiplied by the configured multiplier amount and represented accordingly in the local remote HMI. The range is full range of 64-bit float. The default value is 1. The offset scale factor of the point, B of formula mx plus b, the offset configured for the specific analog input will be added to the injected current/voltage on the respective analog input and represented accordingly in the local remote HMI. The range is a full range of 64-bit float. The default value is 0. Range select, the maximum positive and negative full scale to be applied to the point. The available options are plus or minus 5 volts for the voltage and 20 milliamps for the current. The default is plus or minus 5 volts. The local remote HMI displays the value according to the range selected. Report deadband. This is used to define the reporting threshold. The value is in percent of the full scale. The range is between 0 to 100. The default value is 0.1. Voltage input deadband calculation equals 5. Configured_deadband_value/100 in voltage. Current input deadband calculation equals 20. Configured_deadband_value 100 in milliamps. Point group. Select the point group to which the point belongs. The default point group is PVAL. Adding a new group can be completed via System-wide System Point Groups tab. Note that while working with the client map file, the user can use the copy option to copy the point details into the Excel sheet and then use the paste option to import the point details from Excel after modification. Within the digital input tab, the total number of DI points is 8 and this cannot be changed. Point ID, internal point ID cannot be changed. Point reference, a short identifier for the point, default DI_0x. Point description, a detailed and localized description for the point. The default is DI0x. On state is a text description of the one state which is displayed in the local remote HMI when the respective digital input is on the on state. The default is on. Off state, text description of the 0 state which is displayed in the local remote HMI when the respective digital input is in the off state. The default is off. Note that the constraints on the naming convention for text description for the on state and off state are the same as existing applications in DSAS's configuration tool. Debounce filter MS, length of time used to debounce the noise. The filter is used to eliminate unwanted noise on the digital input, indicating the signal on the digital input must be valid for the configured length of time before the digital input value is changed or reported. The range is between 0 to 1,000 milliseconds. The default is 0. Point group, select the point group to which the point belongs. The default is PVAL. Within the Digital Output tab, the total number of DO points is 4 and cannot be changed. Point ID, internal point ID, cannot be changed. Point reference, a short identifier for the point, default DO_0x. Point description, a detailed and localized description for the point, default is DO0x. On state, text description of the one state which is displayed in local remote HMI when the respective digital output is in the on state. The default is on. The off state is a text description of the 0 state which is displayed in the local remote HMI when the respective digital output is in the off state. The default is off. Pulse count. The amount configured determines how many operations are applied on the respective digital output when a pulse control type is operated. The range is between 1 and 100,000. The default is 1. Pulse on duration, MS. The amount configured determines the duration the relay remains in the on position for a respective digital output when a pulse control is operated. The range is between 20 and 100,000. The default is 1,000. Pulse off duration. The amount configured determines the duration the relay remains in the off position for the respective digital output when a pulse control is operated. The range is between 20 and 100,000. The default is 1,000. Point group. Select the point group to which the point belongs. The default is PVAL. GPIO Runtime Point Details can be accessed through the Point Details page of the local remote HMI. To view these points, click the Point Details button on the toolbar, and once logged into the HMI, click the Details button for the selected GPIO device under the IED tab. The Point Details page displays. Select the Point Type tab or the All Points tab. The points, real and pseudo, and point details appear. To send a control request, right-click the DO point and select the Digital Output interface. GPIO Client also provides some device-level pseudo points. These points are Digital Input DCA status set to 1 if the GPIO device is running normally. Accumulator, control received, the number of control requests received by the DCA via the RT DB that was directed to this application. Control failed, the number of control operation failures detected for this application. Text, device info underscore line ID, the line ID of the device. Device info underscore device ID, the device ID of the device. Device info underscore bay ID is the bay ID of the device. Device info underscore device type, the map file name of the device. Device info underscore device type is the map file name of the device. Lastly, I want to thank you for watching this training content video. And if you're looking for more great content, take a minute and check out the Resources Hub on the GE website. You can do that by typing resources.gegridsolutions.com into your browser, or just click the link in the description of this video and it'll take you right there. Thanks so much for watching, and we'll see you next time.